The structural formula for butyl chloride is CH3, CH2, 3Cl. This is a straight chain chloride, where chlorine atom is attached to the terminal carbon atom of the butyl group. The nomenclature of butyl chloride can refer to several isomers, depending on the position of the chlorine atom and the structure of the butyl group. The main isomers are 1-butyl chloride, or known as N-butyl chloride. This is the straight chain version, where the chlorine atom is attached to the first carbon of the butyl group. Its IUPAC name is butane 1 chloride. Next, we have 2-butyl chloride. This is the isomer where the chlorine is attached to the second carbon of the butyl chain. Its IUPAC name is butane 2 chloride. After that, we have isobutyl chloride. This is the branch form of butyl chloride, where the chlorine is attached to the first carbon of the isobutyl group, which has a branch structure. The IUPAC name for this is 2-methylpropane 1 chloride. Lastly, 3-butyl chloride. This is another branch isomer, where the chlorine is attached to a carbon that is part of a 3-butyl group. The IUPAC name for this is 2-methylpropane 2 chloride. Each of these names refers to different structural arrangement of the butyl chloride compound, and they all contain the chlorine atom bound to a butyl group, C4H9. Butyl chloride has several chemical properties, including reactivity, acidity, and hydrolysis. For reactivity, butyl chloride can undergo nucleophilic substitution reactions. This is because the chlorine atom attached to the carbon can be replaced by other nucleophiles, such as hydroxide ions, alkoxides, or amines, depending on the type of butyl chloride, whether it's 1-butyl chloride, 2-butyl chloride, or isobutyl chloride. The rate of reaction may vary. For acidity, butyl chloride is slightly acidic, as the chlorine ion can act as a weak base in some reactions, but it is not as reactive as other chlorides like alkyl chlorides. For hydrolysis, butyl chloride can react with water in the presence of a base or acid to form butanol and hydrochloric acid via a nucleophilic substitution mechanism. This reaction occurs more readily under acidic conditions. Butyl chloride has several notable physical properties. The appearance may appear as a colorless liquid at the room temperature. The boiling point is approximately 78.5 Celsius or 173.3 Fahrenheit. The melting point are around -100 Celsius or -148 Fahrenheit. The odor is unpleasant and sharp. The density of butyl chloride is 0.886 gram per centimeter cube at 25 Celsius.
Synthesis method and natural source of the molecule for 3-butyl chloride. The 3-butyl chloride is synthesized through a chlorination reaction of 3-butyl alcohol under the catalyst of a metal chloride. 3-butyl chloride is produced by the reaction of 3-butyl alcohol with hydrogen chloride. In the laboratory, concentrate hydrochloric acid is used. The synthesis of an alkyl halide by reacting the corresponding alcohol with the hydrogen halide in an easy and expensive S1 reaction. 3-butanol reacts greatly with HCl and forms the corresponding 3-butyl chloride at room temperature. Its N1 mechanism are unimolecular because the slow step is unimolecular. The reaction proposed involves an initial step where the 3-butyl ion is formed by protonation. This ion dissociates to a second intermediate, a carbocation, an ion that contains a positive charged carbon. The carbocation, being strongly electrophilic, then reacts with the nucleophile chloride ion, the 3-butyl chloride final product. The nucleophile is not involved in the rate determining step of the process. A strong nucleophile are not important. The SY mechanism is generally accepted for the reaction of tertiary and secondary alcohols with a hydrogen halide, but not for methyl and primary alcohol. As methyl, primary carbocation are too unstable to be reasonably involved. Methyl and primary alcohols will suffer additional protonation and then react slowly by a bimolecular SN2 mechanism. If the same condition were applied to an butanol the small amount, it will be obtained.
Last but not least, there is 6 practical applications of butyl chloride. First, chemical intermediate, used in the production of pharmaceuticals, agrochemicals, and dyes, serve as a precursor to butyl lithium, a reagent in organic synthesis. Second, solvent, acts as a solvent in the manufacturing of resins, oils, and rubber, used in organic synthesis for reaction requiring no polar solvents. Third, industrial cleaning and degreasing, implied in degreasing metal surface as machinery due to its ability to dissolve oils and grease. Fourth, gasoline additive production, used in synthesizing butylated compounds that enhance fuel efficiency and performance. 5. Pesticides and herbicides plays a role in the synthesis of certain pesticides and herbicidal formulation. Last, laboratory use, utilized as a reagent in chemical research and organic synthesis.
significant in various industries. First, pharmaceuticals industry used as a precursor in the synthesis of pharmaceutical compounds in the production of anesthetic, sedative, and other medicinal drugs. Second, chemical industry acts as an alkylating agent in organic synthesis, essential in manufacturing butyl lithium, a key reagent for polymerization and synthesis, used to produce other halogenated organic compounds. Agrochemical industry used in the synthesis of pesticides, herbicides, and fungicides, help improve crop protection formulation. Chemical industry used in field activities to improve gasoline performance, plays a role in the production of lubricants and other petrochemicals derivatives. 5. Paints and coating industry functions as a solvent in paint removers, coatings, and adhesive. Contributes to the formulation of curtain, especially coatings. 6. Rubber and plastic industry. The vulcanization of rubber used in the production of plasticizers, which enhance the flexibility of plastic. 7. Laboratory and research. Employed in organic synthesis experiments. Use a reagent in developing new chemical compounds. And last, 8. Textile industry. Involved in curtain dyeing process. Help improve fabric treatment formulation.
Chloride, such as butyl chloride, also known as C4H9Cl, play a significant role in organic chemistry due to their reactivity and use in various synthesis processes. Butyl chloride, specifically, is a primary alkyl halide that finds application in the production of other chemicals, pharmaceuticals, and as a solvent in organic reaction. Its reactivity stems from the pollination of the carbon-chlorine bond, making it an important intermediate in substitution and elimination reaction. Understanding the properties, synthesis, and reactivity of chlorides like butyl chloride is essential for advancing knowledge in organic chemistry and developing new industrial applications.